All right, so acid-base indicators. We do something called titration, and we use these indicators a lot of times to tell us when we're at a certain point within that titration. Okay, so a titration involves typically a substance in here, either an acid or a base. In this case, they're going to say an acid for this situation. And for your lab next week, that's what's going to be in here is an acid. You'll also have an indicator in there. The one that you're going to have in yours is going to be phenolphthalein. And then you have a burette here, which is a really long tube that has a point at the end. And then it also has a device here that you turn manually that's called a stopcock. So that stopcock prevents this material from flowing through here, or if you turn it the right direction, then it enables it to flow through. Also, typically down in here, you will have, like for your lab, I typically have you put a magnetic stirring rod in the solution. And underneath that then is a magnetic stir plate that will turn that stirring rod to keep the stuff mixing all the time. Okay. Most acids and bases are colorless. So if you put an indicator in here that indicates at the point where that pH difference, where it's going to have your equivalence point, if you have an indicator that changes at that pH time, then that's what that color change will indicate to you. Okay, and if you put a piece of white paper between the stir plate and the flask, then it's a little bit easier to see it because it's just this real super faint color of pink that you'll be looking for next week. So the phenolphthalein changes right at the point where it changes from like 7 to 8 for your pH. And that neutral point is where you'll be at your equivalence point for the acid base. Equivalence point means that you have an equal amount of moles of acid to base at that point. So your equivalence point will be the moles of acid or hydrogen, H plus, equal the moles of hydroxide at that point. Okay, so indicators, like I said, change color at their end point. So you want an indicator that's going to change and coincide with that equivalence point. And the one that we're going to, like I said, we're going to use is phenolphthalein, which is a good one when you have a strong acid, strong base, which is what you're going to be doing for your lab this week, next week. Okay, weak acids and conjugate bases are different colors. So this methyl violet is purple, and then the methyl violet with a hydrogen attached to it is yellow, and so that's going to change over. We also have something called universal indicator that has several different indicators like within it, and it'll have different color changes all the way along the line. So if we're looking for the Ka expression for this weak acid, what would that look like? Can you draw that on your paper? We talked about Ka yesterday, and you had some practice with that in your homework from yesterday if you did the homework. Okay, so remember your Ka expressions are the concentration of your products over the concentration of your reactants. So that's what your Ka expression for that weak acid would look like. Okay. Halfway through the color change, then these things are going to be equal so that the pH at that point would equal what's called the pKa. So you can actually take this pK or this Ka and do the negative log of your Ka, and that's going to equal your pKa. And your pKa will equal your pH at the half equivalence point, which is going to become important when you come into AP Chem. That's a big one to kind of have in the back of your head. Okay, so here are some gradual indicators of this. This phenolphthalein is what we're going to be using for our lab. And when you get that faint pink color, then you know that that's where you want to stop and take your calculations. And the gradual shift is usually 1 plus or minus 1 pH unit, and that gives your eyes time to kind of understand that color change. And some people's eyes are more sensitive than others. You can actually see it sooner than other people. All right, so how do you know what's appropriate indicator for your acid or base titration? You want your indicator's endpoint or change color to be around the same pH when the equal amounts of acid and base have reacted. So here's your methyl violet, 0 pH, pH of 4. Here's your methyl orange, pH of 2 and 7. So you can see the difference in these colors pretty drastically. Bromothymol blue is 4 and 10. Here's your phenolphthalein. So this is what you're going to be working with. If you go over and add too much base in, it'll be this darker pink color, and you do not want that. If you get that, then you're going to go back to your burette and you're going to add more acid in to get it to shift back to this color. And then you can go back and add base to get it to the light pink. So this is recoverable. This, you know, if you goof, you just go back and add more of this, and then you add more of that. And then you don't take your final readings until you get that nice light pink color, because then you're like, okay, now we're good. All right, so titrations. You guys are going to be doing this one. You're going to be doing a strong acid, strong base. So you're going to have NaOH for your strong base, and you're going to have HCl for your strong acid. I guess it's written right there. Your weak acid, you could have a weak acid and a strong base, which is like acetic acid and an NaOH. You could have a strong acid and a weak base, which would be HCl and ammonia, for example. The net ionic equation then for any strong acid base reaction is this. So you're making water. The other thing that you're going to make when you do yours with the HCl plus NaOH, when it's neutralized, you will have water in there and you will have NaCl. So you're making salt water essentially. Okay. Opposite of the ionization of water, so the reciprocal rule applies. Large value for K indicates that the reaction is going to go to completion. So one of the common things that you'll see on like an AP exam is they might give you a graph like this and ask you what's being titrated. So this would be in your flask, and it's being titrated with a base here. And you know that it's a strong acid and a strong base. And you know that because of the pHs here. It's starting out way down here at 0, and it's going all the way up to 14. This would be the opposite. Here you would have the base in your flask, and you're titrating it with acid. The other thing is that, remember that pKa, so the half equivalence point, if you wanted to figure out where your half equivalence point was here, where that's about halfway through this. So if you knew that this volume, for example, was 40 milliliters, let's say, then your half equivalence point would be what? How many milliliters? Half equivalence point would be how many milliliters? 20. So if you knew that this was at 20 here, and you knew the pH was right here, you could figure that out. that would give you your pKa value, because remember at the half equivalence point, that equals the pKa. And then if you take 10 to the negative pKa, that's going to give you your Ka value. So that way you can come up with your Ka value. Sometimes they ask you to tell the Ka value from these graphs, and that's how you would do it. So what do you notice about the titration curve? Again, the pH, that degree of steepness, you notice that the equivalence point here. For these, the equivalence point is always at 7. And that makes sense because you got a strong acid and a strong base. They're both strong. Your equivalence point is going to be at 7, which is right in the middle. Okay. Then if we look at a weak acid, strong base, what does that look like? Okay. You are going to end up with something that looks like this. Now notice here that your pH is starting not at 0, but down, up a little bit because it's a weak acid. Your strong base is still going to end up way up here. The steepness, the curve isn't quite as steep as the other one. And the equivalence point here is no longer at 7. It's gone up because this is a strong base. Here, this is a weak acid. So that equivalence point is going to be greater than 7. Does that make sense? All right. Strong acid, weak base. The opposite is going to be true here. So again, the equivalence point, the graph, the curve isn't quite as steep. Your starting pH, though, is no longer going to be at 14 as we had when we had a strong base starting out. It's going to be less than that. Your equivalence point is going to be less than 7. And then since it's a strong acid, it's going to end up somewhere around 0 for the ending pH. So we've got hydrochloric here. And we've got NaOH. When you have hydrochloric and NaOH, you can use this M1 V1 equals M2 V2 equation that we learned before. If it's a weak acid, strong base, weak acid, any of the weaks in there, you can't do this method. But if it's strong, which is all we do this year, you can do this. You cannot do this with weak stuff, though. So if you come into AP with me, this is not going to be the solution that you're going to get to use. This is just a nice, oh, this is easy. Next year, it gets more difficult. But for your lab that you're going to be able to do, you can do this, okay? So this is going to be your M1 and your V1, okay? This is going to be your V2, solve for M2. M1, V1, V2, solve for M2. And then see if you can figure out how to do number 2 as well. So for this first one, I ended up with oh shoot, it's going to do that to me again. 1.392 molar. Good. And then this one, I ended up with 0.0728 molar. Okay. So this one, this was my M1 V1, and then this would have been my V2, or vice versa. It doesn't matter. So this molarity and this volume go together, and then you're dividing by that volume. So multiply these two together, divide by that guy, and you've got your answer. Okay, good. So that's what we're working with. I think, just double check here. You've got some work to do in your packet for titrations. So you got a couple pages there to work on. The other thing that we need to talk about real quick, which I did not have in this slideshow apparently, is how to properly read a burette. So let me go out and here and Google image and see if I can find some burettes. Because it's different, okay? So let me pull up a diagram here. So you're used to, when you do these, you are used to having a higher volume up here and a lower volume here. Okay, so this is completely backwards, and you have to kind of get used to that. Okay, what you're doing is at the top of this burette, you're starting out at 0, because if you have that thing all the way full, you haven't added anything in yet. Okay, you open that up, you're starting to drain out. You're going to have let out so much. So at this point, they've let out over 34 milliliters. So this would be 34.1, 34.2, and then you're partway in between that. So this would be like 34.29 would be the volume on this. And these burettes, you should always get to the 100th place for the reading. Okay, so here's another example. Well, here's one that's probably bigger. Here we go. So here, if we're looking at this one, this is 19, 19.1, 0.2, 0.3, 0.4. This would be 19.5 for the answer. But again, you know, you've got to kind of get used to reading this, and you've got to get used to reading it backward. And that's what we're going to be working on Monday, is how do you load these things? How do you read the volume on them? How do you, so I'm going to tell you, okay, I want you to drain it down, and I want you to show me a volume of 23.45 milliliters. Okay. And then I'm going to come around and check to see if you got it or not, just so that you can get used to reading these, because it's counterintuitive, and it's a little tricky to get used to the reading of these values. So like this one isn't at 0 right now. This would be at like 0.2 or 0.28, I would give it. Okay, and that last digit, remember, that's where our significant figures come from, because that last digit is an estimate. So you may look at this and go, nope, that's 0.29, and it would be right, because that last digit is an estimate. Okay, so I will give you some time to work on that stuff. If some of you have stuff that's still out, make sure that you get that material to me, so that I can get stuff graded for you, and make sure that everything's in the book before we move on. So, all right.